Hi there. So, over the last two lessons, we've been looking at this concept of rates. So, we understood that rates compare quantities measured in two different units. And so, we found a whole range of different rates that we use in real life. So, we've understood that we can see some people talked about interest and how it's percentage per annum or annual or year. And some people were talking about uh, speed as kilometers per hour, meters per second. We talked about examples regarding different units that we don't expect, such as like teachers per student or books per days. And a lot of different variations because it could be really two different quantities as long as they work together, we can compare them. And so today we're actually going to be looking at a specific example of a rate. We're going to be looking at speed today. It is a rate that is used a lot in with a lot of different applications, and so we're going to be looking at speed. Basically, it's just a measure of how fast an object is traveling, which makes sense. It's something that we all really know already, um, and we may have been exposed in the past the speed, distance, time triangle. This triangle helps us to understand the relationship between speed, distance, and time. If you think about it, when you've been looking at speed in the past, even if I asked you, give me an example of a speed, a lot of you would say something like a number with kilometers per hour. And if you work with, perhaps you might say meters per second. Those are the two common speed units that are used. Now, you may have noticed that when we say kilometers per hour, after we just did our rates unit just a couple of lessons ago, you would have figured out, or potentially you would have been able to see, well, wait, this is two units in this array because it's comparing these two units. Here's a unit of distance, here's a unit of time. Just like with meters per second, here's a unit of distance, here's a unit of time. Basically, speed, if we are thinking about it, is a rate, the rate being the two units being compared being the distance and the time. And we've learned this per understanding before. So when we say kilometers per hour, we've learned this, we can write this as kilometer slash hour. And we've also learned this concept of percentage, so per 100 rather than percent. And so we know that we can take a number like, let's say 90%, and we understand that also means 90 per 100. And so when we do kilometers per hour, we are literally doing kilometers per or divided by hours to give us an understanding of the speed that they're traveling. Okay, with this triangle, it helps us to understand what the formula can be. In this case, the distance that is at the top, because we can use this variation to determine that the distance we can figure out the distance if we have speed and time. And by doing that, because speed and time are in the same horizontal line, they're being multiplied together. Whereas for time and speed, notice that the distance is at the top of the triangle and time is at the bottom, and hence these are vertically showing vertically, and so it's distance divided by time or distance per time, and here time is equal to distance divided by speed or distance per speed. That's how you read the triangle. Okay, I'm going to take one of these triangles with me. You can have this with you, and eventually you hopefully memorize it. It becomes really, really easy to just recall when the time comes. So here's a demonstration of how you can approach these questions. I'm going to put the distance, speed, time triangle in here. Distance, speed, time triangle. And we're just going to use this to help us to do these sort of questions here. Question first asks, find the average speed in kilometers per hour. That's really important, by the way. Make sure you are aware that asking this means that your answer has to be comparing kilometers per hour as those units. For question A, we have a cyclist who travels 140 kilometers in 5 hours. We're given a distance and time, and we're given them in the correct units. This one's in kilometers, this one's in hours. So we're our feel-good start. Now we use this triangle to help us to figure out what the formula should be. Here, the formula is we need to figure out speed, so it's S equals, I'm looking at S, and I can see that the D is on the top on this side, and then T is at the bottom. So it's distance over time, which is equal to, well, the distance here is 140 divided by 5, and hence the speed, if we were to do the maths here, is 28 kilometers per hour. Right, so that's how you approach the question. Let's see the second question. A runner who travels 3 kilometers distance, also in the right unit, in 15 minutes. Now, here's where some of you should have warning lights. This is not minutes. This is in minutes, not hours. So if we need to do this correctly, need to convert this 15 minutes to hours first before we do the maths. So the first thing I need to do is understand that 15 minutes, so we're going to convert this first. 15 minutes is equal to 15 divided by the number of minutes in an hour. So that, if you know common knowledge, 60 minutes, okay? Which is equal to 1/4, or I guess you can say 0.25 hours, depending on what you want to use, okay? Now, by doing this, we can actually use that to figure out what we need. So speed is equal to distance over time, okay, which is equal to, in this case, 3 divided by 0.25, or another way to visualize this, because 3 divided by 0.25 might be too much for you guys, for some of you. Another way to visualize it is it's 3 divided by 1/4. Remember, we figured out this 1/4 right here, up here, okay? So 3 divided by 0.25 is the same as 3 divided by 1/4, and we've done fraction division before. So this is just, of course, 3 times 4, because KFC, keep the first fraction, flip the second fraction, and change the sign. That's what I did. So I flipped the second fraction. I guess you can do it like this if you want to. 3 times 4 is equal to 12 kilometers per hour. Okay? You don't have to, I'll just highlight it, you don't have to do this if this is confusing for you. Instead, you can choose to do this if you feel more comfortable with fraction of division, which you should, because we've done it before. Okay, let's try the next one. Here we have find the distance traveled by a truck traveling for 15 hours at an average speed of 95 kilometers per hour. I am going to take my distance speed time triangle down here with me, because I'm going to use it. And I'm going to ask myself, what am I looking for? Okay, the question says find the distance. Great, I'm looking for the distance. Here's distance, which means my question starts off by going D is equal to something. Now I'm looking at the relationship of speed and time, and I see that they're in the horizontal here. Okay, they're on the same line, hence it's speed times time. And now I can work with this because I have a speed, which is 95 kilometers per hour times 15 hours. This works, notice, because this is in hours and this is in hours. If it weren't the same units, you would have to convert so that they were the same. But right now, we're lucky we don't have this, so we can just work with this straight away. 95 times 15, we can quickly do it if we want to. Oops, 95 times 15. Just operate like this, okay? So if you don't know off the top of your head, just operate. Let's just do it. So 5 times 5, 25, 5 9 is 45 plus is 47. Magic 0, 1 times 5 times 5, 1 times 9 is 9. So we've got 5, 2, 1 here, so this becomes 14. So here I have 1425 kilometers. And there's my answer, okay? Obviously, this is just to show you that sometimes you might not know something on the top of your head, and so just doing something like this is perfectly legitimate. Okay, so use anything that you know to get to the answer, especially if you don't have a calculator. In this case, yeah, you might want to use a calculator for something like this, and that might be okay, but just to always have something on the back of your in your toolkit to be able to use. Finally, bringing this down with me, find the time taken. So time is my subject. This is what I want. I want time taken. and I'm looking at time taken over here, and I can see that distance and time are vertical, so time is equal to distance to the speed, which is equal to distance, which is 15 kilometers over 4. I can do this because they're both kilometers. Remember, if they weren't the same units, you would have to adjust and convert, but they're the same, so we're lucky. And then we just find out what this is. So here's 15 divided by 4. If you don't know what 15 divided by 4 is, it's fine. Just quick, very nice and quick. 4 goes into 15 3 times with a remainder of 3. And so I guess you could do this if you wanted to. You could put the remainder of 3 here to get a decimal answer if that's something you prefer. So 4 times 7, so 28. So 7 goes into here, remainder of 2, 5. So 3.75 hours. I know it's hours because the units tell me it's hours over here. So just be aware. I only know it's hours because it's given to me. I can't assume any time. I need to actually know what is written in the original question. For these questions, you have to be hyper aware of what detail, what information, what units they're given to you, or else you're going to find yourself in a difficult time. Okay, so give that a go. Of course, you could also, just to give you options depending on what you want to do, this is also a mixed fraction, so this would actually be 3 3/4 hours. Which would have been totally fine as well. You know, some of you would know that 3.3 and 3/4 hours is the same thing as 3.75 hours. Both of them are valid answers. Okay, so give it a go. Hopefully it helps. You have the questions given to you over here. I'll see you next time.